Welcome to this presentation on the factory design pattern. This is being presented by Carlos Gomez and myself, Jonathan Roberts. Let's jump right into it.
What is factory design pattern? Factory design pattern is a creational pattern. This means that it is a pattern that deals with the creation of object mechanisms. It creates objects in a way that satisfies the situation. It is a method that can create objects without the use of a constructor. It instead makes use of subclasses inheriting from a superclass to create the new objects. A great feature of this pattern is that it can create various types of objects without specifying the type of object it creates until it is runtime. This is done by creating an interface that is then implemented by subclasses. The subclasses are then in charge of specifying the type of objects to be created. When to use factory design pattern? We can use factory design pattern when a class cannot anticipate the type of objects it needs to create beforehand. A reason to use factory design patterns is when you need to create various types of objects, but you don't know for sure what kind of objects are needed to be created. There are different types that an object can be assigned to, so specifying a type in a superclass will not work when you are trying to use different kinds of objects. Another reason to use factory patterns is when a class requires its subclasses to specify the objects it creates. The superclass won't assign the type for the objects. Instead, it gives this task to the subclasses. The subclasses then assign the type for the objects that are being created. Another reason is when you want to localize the logic to instantiate a complex object. Factory patterns make it easy for the programmer to localize the objects so that these new objects can be instantiated in the subclasses. Factory design UML example. Here we have a small representation of how the factory design pattern works. The factory design pattern defines an interface for creating objects, but allows subclasses to decide which classes to instantiate. In this example, we had 3 boxes. Our interface is represented by injection mold, which is a top box. Then we had 2 subclasses. Our first one is toy dog mold, and the second one is toy car mold. For this example, we are going to use the process of an injection molding press. Manufacturers of plastic toys process plastic molding powder and inject the plastic into molds of the desired shapes. Here the subclasses define what the actual mold of toys is going to be used, either toy dog mold or toy car mold. In other words, the subclasses are the ones who specify the type of objects that will be created through the implementation of the interface injection mold.
So what are the advantages of using the factory design pattern? Well, first it provides an interface for the implementation of the code to create objects. In doing this, it removes the actual implementation of the classes into the factory. What this means in a coding example is that the new keyword is not called in the method where you want to create the object, but instead a new factory is called. The factory's method is called to create a new object. And then that factory does the work of creating the objects using the new keyword. But the new keyword, again, is not used in the actual method, thus creating this interface. This is seen as a very good thing in modern object-oriented programming, making the code robust, it's decoupled, and easier to extend. In addition to the interface, We also get the advantage of abstraction in a special type of factory called the abstract factory pattern, where you can have an abstract class and an interface factory at the same time. So are there any disadvantages to using the factory design pattern? Well, truthfully, our group had to dig pretty deep to find anyone talking about disadvantages of the factory design pattern, but we did come up with a few things that were discussed. The first one that was discussed the most frequently was the idea that the factory design pattern can make code more difficult to read and comprehend. And this makes sense because instead of creating an object where you would expect it to be created, you are now creating a factory object, something that isn't necessarily expected. And then that factory is using polymorphism to create the object that you need. So there is definitely more code, and it would be harder to follow. Another negative that came from our research is that although the factory design pattern generally is seen as a decoupling mechanism, it does create more coupling between the different layers of the code. So in other words, a service implementation layer can have more coupling between itself as you are creating an object. Although the factory design pattern's overall decoupling is seen as a bigger advantage, this is something to consider. And the final item that we found as a disadvantage is that the factory design pattern can be used incorrectly quite easily, particularly when it is overused. Perhaps instead of using dependency injection, people try to do it through the factory design pattern. So how can the factory design pattern be used in Hack? Well, the item that I thought about that might best suit the factory design pattern would be the idea of creating tasks and assignments, because they're generally the same thing and they can be done from an interface. I had a little bit of a difficulty deciding what to call an interface between a task and an assignment, but I came up with items do. Of course, we can change that. So from the Hack view, a user is going to click on an item where they want to create a task or assignment. Instead of having that object created directly, we would have an items do factory. And in that items do factory, we would create the get items do. That would go into where this work would be done for the factory, creating either the task or the assignment. And from the items due factory, we return the new item due, whether it be the task or the assignment. Thank you for listening. I hope you've been able to learn something about the factory design pattern. Of course, if you have any questions, you can feel free to reach out to Carlos or myself.